Hello, welcome to the video session on sampling theory. I am providing you today, I'll be providing you with the solutions for the questions which has been raised earlier on sampling theory. Uh, I would like to provide a brief idea about the concept of sampling theory. It goes as follows. The importance of the theory of sampling lies in the fact that for a large population, it is neither practical nor possible to collect data for each and every number of the population. The purpose of sampling is to get information about the population from the sample. To the extent to which we can do this with any accuracy depends on the choice of our sample or samples. The major advantage of the sampling is that it is very convenient and economical to provide any uh, overall observations and forecasting. The first question, it runs as follows. A population consists of 50 members. Random samples of size 2 are drawn without replacement. The possible number of samples is as follows. Going to our work area, population size is given to be 50, sample size is equal to 2. Possible number of samples without replacement is nothing but 50 C2 or 50 choose 2, which works out to 1225. Going by the option, it is option C. Going to our video PowerPoint, it is option C, which says 1225. Question number 2. Random samples of size 2 are drawn from the population units A, B, and C with replacement. Then the possible samples are, we can find out from the option. The possible samples could be, because there is a repetition or a replacement, it is option C, which says A, A, B, A, C, B, 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 C, C, C. In fact, it should have actually the total solution should be with replacement should be 9. 3 squared, that is 3 into 3, because there are 3 elements and you are picking 2 samples, and the sample size, that is size is 2. Moving over to third question. From a population of size n, samples of size r are drawn without replacement. Then the number of possible samples is nothing but a combination of selecting r people from the total n. So it works out to be NCR or N choose R, which is a C option. Go into our PowerPoint presentation. The solution is option C, which says NCR. Fourth question. Samples of size small n are drawn from a population of size capital N. If the samples are drawn with replacement, then the possible number of samples is the maximum. That is, you see the work area, population size is capital N, sample size is small n. With replacement, we have to work out. So total possible number of samples would be n. Again, you will have n options. You will have n items can be picked out. So this will go for small n times, which is equal to capital N power n. So the answer is option A. Go to our PowerPoint presentation, which says option A, which is capital N whole power small n is the answer. Fifth question. If population standard deviation is known to be 6 for a population containing 100 units, then the SC, that is the standard error of the sample mean for a sample of size 25 without replacement would work out as follows. We know the population capital N is equal to 100 units. Standard deviation of the population sigma is equal to 6. Small n, sample size, is equal to 25. Therefore, standard error of the mean, that is sigma x bar, is equal to sigma by root of small n into root of capital N minus small n by capital N minus 1, substituting the relevant values as shown here. We work out as the value as 1.4446, which is option C. Going back to our PowerPoint presentation, the answer is C option, which says 1.04446. Sixth question, a simple random sample of size 16 is drawn from a population with 50 members. The standard error SC of the sample mean if the population variance is known to be 25, given that the sampling is done with replacement. Going back to our work area, small n indicates the sample size of 16. Capital N is nothing but the population 50. Now, variance, that is sigma squared, square of standard deviation, is given to be 25. So, sigma, that is standard deviation, is 5. Now, standard error SE with replacement works out to, is given by the formula sigma by root n, substituting the relevant value small n, that is, so 16 5 by root 16, which is 1.25. So the answer is option B. Going to our PowerPoint presentation, it is option B, which is 1.25. Seventh question, a random sample of size 3 is taken from a population with items 1, 3 and 5. The estimate of the standard error of sample mean is worked out as follows. Population with items 1, 3 and 5. Now the sample size is given to be 3, and so therefore x bar would work out to be 3, because 1, 3 and 5 items are there. Now standard error is nothing but sigma x bar, which is given by square root of this is with no, this is anyway, standard error is equal to sigma x bar, which is equal to square root of sigma of summation of x minus x bar, the whole squared, and when we divide by n minus 1, so sigma xi minus x bar whole squared works out to be as follows: minus 2, that is 1 minus 3 whole squared is 2 squared, that is minus 2 squared will be 4, then the other one will be 0 squared, then the other one will be 2 squared. So when you add up all of them, you get 8. So sigma, therefore sigma x bar, that is the standard error, is equal to square root of 8 by 3 minus 1, which works out to be 2. So the answer is option B. Going to our PowerPoint presentation, it is B option, which says it is 2. Eighth question, a random sample of size n is taken from the population set 1, 2, 3, 4, etc. up to m items, m consecutive numbers from 1. It means then the standard error of the sample mean has to be worked out. Going to our work area, population set is 1, 2, 3, that is m set of positive integers from 1 consecutive integers. So the size is m, sample size is n, standard error is given by sigma, that is the standard deviation of the population, divided by root of small n into root of capital N minus small n divided by n capital N minus 1. Now standard deviation of the population sigma, which is equal to square root of, it is worked out as m squared minus 1 by 12, which we know it earlier itself. It's a very standard thing. Therefore, standard error is equal to, substituting all the values and simplifying, we get the value as square root of m plus 1 into m minus n divided by 12n. So the answer is option A. Going to our PowerPoint presentation, the solution says A option, which is square root of m plus 1 into m minus n divided by 12n. Ninth question, if it is known that 95% confidence interval is 48.04, 51.96, the value of the standard deviation of the population for a sample size of 100 is worked out as follows in the work area. Naturally, this is talking about a Gaussian type of distribution. So 95% confidence interval is 48.04 to 51.96 range, and given the sample size is 100, we need to compute standard deviation sigma of the population. We know the formula that, seeing the figure here, for a 95% confidence, the interval is between 48.04 to 51.96. That is x bar minus 1.96 sigma root n to x bar plus 1.96 sigma root n. So that is the interval. So substituting the values of the interval accordingly and subtracting from equation 1 from equation 2, we get the value as 3.92 sigma by root n equal to 3.92. So sigma works out to be equal to root n, and n is given to be sample size is 100, so root of 100 would be 10. So the answer is option B. Going to our PowerPoint presentation, it is B option, which says it is the standard deviation is 10 of the population. 10th problem, if P probability is 0.2, what is the sample size to ensure that the error of estimate for the population proportion should be more than 5% at 95% confidence level? Going to our work area, probability is given to be 0.2 for 95% confidence level. Z is 1.96. If you can go back to our earlier problem, I would have explained, you would have had a formula wherein that 1.96 comes. X bar minus 1.96 into sigma by root n, or bar plus 1.96 into sigma by root n. So that 1.96 is your Z. Now we need to find the sample size n, which is given by P into Q. That is, Q is nothing but 1 minus P, and into Z squared by E squared, where E is the error percentage for 95% confidence level. So which is equal to 0.05 or 5%. So substituting those values, you get it as 245.86, which is rounded off to 246. So when you look at the answer, the option is A. Going to our PowerPoint presentation, it is option A, which is closest to 245.86, that is 246 rounded off. So A is option, answer is 246 is the closest answer. 11th question, the 95% confidence interval for a population proportion, the interval is 0.06 to 0.16. The sample proportion needs to be calculated. Now 95% confidence is given. 95% confidence lies in the interval 0.06 to 0.16. In that interval, we have that confidence level. Now sample proportion needs to be calculated, which is nothing but the probability p. Now, expressing the interval in terms of the probability and the sample size. Now, sample proportion or the probability p is p minus 1.96 into root of pq by n, which is the lower limit, that is 0.06, p plus 1.96 into root pq by n, which is equal to 0.16. So when we add both the equation, we get 2p equal to 0.22. The other two terms get cancelled, so p is equal to 0.11. So the answer is option D. Going to our PowerPoint presentation, which says the sample proportion is 0.11, which is option D. 12th question. In a sample size of 400, the calculated standard error of mean is 2 with a mean of 70. What sample size would be required so that at 95% confidence interval, the population mean with plus or minus 3.5 of the sample mean? Going to our work area, for sample size n equal to 400, standard error is given to be 2 and the mean of the population mu is 70. We know standard error is given by sigma, standard deviation of the population, by root n. So we work out as the standard deviation of the population to be 40. Now, with the standard deviation of the population being 40 and the z value of 1.96, we are also given for 95% confidence interval, the population mean is plus or minus 3.5 of the sample. That is, E is equal to plus or minus 3.5. It is the okay. Now, therefore, new sample size n1 can be calculated as z into sigma by E whole squared, which on working gives you 502. So the answer is option A. Going to our PowerPoint presentation. So the new sample size with the condition that 95% confidence interval, the population mean given to be plus or minus 3.5 of the sample mean, the option is A or 502. இன்னுமே அடி படுத்து வாங்கிடலாம். Now, right. 14th question. A statistical population may be, from the four options, it can be finite or infinite. This is the general property of any population that we can consider. So the answer is C option, which says finite or infinite. 15th, a random sample of size 3 are chosen from a sample of size 12 without replacement. The probable number of samples would be, it is the capital N is 12, that is the, you can take it as a population 12, that is the bigger sample, out of which we are choosing a random sample of size 3. So the actual value should be, without replacement means it is 12C3 or 12 choose 3. So the answer is option A, which is 12C3. 16th problem, a statistics is, out of the four options, a function of sample observation, which is given in as B option, which says a function of sample observation, and this is the definition of statistics governed by the four option. B option is the appropriate one, that is a function of sample observation. 17th question, standard error of a sampling distribution is the standard deviation of a statistics. This is as per the definition of standard error, so it is the D option, which says the standard deviation of a statistics. 18th question, population mean, out of the given option, it is a parameter. So as per what exactly a population mean represents, it only represents a parameter, so it is a B option, which says a parameter. 19th question, the standard error of mean in the case of a finite population of size n and sample size small n without replacement is given by this formula, sigma by root n into the whole root of n minus capital N minus small n by capital N minus 1. This is without replacement as per the real property or the concept of standard error of finite population of size n and sample size small n without replacement. So going to our PowerPoint presentation, it is a D option, which says sigma by root n into square root of the entire square root of capital N minus small n by capital N minus 1. 20th question, the standard error of population proportion in the case of finite population of size n and samples of size small n drawn with replacement. As per the formula, the standard error is equal to square root of P into Q by small n. This is the formula that is derived. So going through the PowerPoint presentation, it is the A option, which says square root of PQ by L. 21st question, sample variance is a biased estimate for the population variance. This is as per the definition of sample variance. Going to our option, it is A option, which says a biased estimate for the population variance. 22nd question, an estimator is an ideal estimator if it is an unbiased estimate and consistent, and it is sufficient and efficient. So it is both A and B option put together, which is given as the D option. So the answer as per PowerPoint presentation is D option, which is the combination of A and B, that is unbiased and consistent, it is sufficient and efficient. 23rd question, sampling distribution is Nothing but probability distribution of a statistic. Out of the four options, it is sampling distribution is the probability distribution of a statistics. Going to the answer, it is the B option which says probability distribution of a statistics as per definition of sampling distribution. 24th question. In sampling, standard deviation is known as sampling error. As per a PowerPoint option, it is B option which says sampling error. This is in accordance to the definition of standard error. 25th question. Which sampling is subjective to the discretion of the sample? It is the purposive sampling. So it is as per PowerPoint presentation. The solution is the D option which says purposive sampling. Well, we can go to the various types of sampling. So we can find out that the subjective sampling to the discretion, the sampling is subjected to the discretion of sample is nothing but purposive sampling, or the D option. 26th question. The dash of the sampling distribution of a statistics is called its standard error. From the option, actually it is the standard deviation of the sampling distribution of a statistics is called its standard error. This is as per the definition of standard error, SE. So the answer is A option which says standard deviation. So the standard deviation of the sampling distribution of a statistic is called its standard error. 27th question. A statistics is nothing but, out of the four options, it is the standard error. This is as per the definition of statistic. Going to our PowerPoint presentation solution, it is the D option which says the standard error. So a statistic is the standard error, the D option. The 28th question. The sample standard deviation is a biased estimator of population standard deviation in the case of the D option, that is infinite population. This is as per the definition of biased estimator. So the answer is D option which says infinite population. 29th question. A random sample of size 81 is taken from a large normal population with a standard deviation of 3. The standard error SE of mean is as follows, worked out in the worksheet as standard error of mean SE equal to sigma, that is the standard deviation of the population, divided by square root of n, which is the sample size. Here sigma is 3 and sample size is 81, so the value works out to be, as per the formula, it is 1 by 3. So the answer is option C. Going to our PowerPoint presentation, it is option C which says 1 by 3 is the standard error of mean. 30th problem. A random sample of 400 male students is found to have a mean height of 171.38 centimeters. The mean and standard deviation of a large population is 171.17 and 3.3 centimeters respectively. 3.3. The standard error of mean is as worked out in the example, the worksheet. Sampling size is 400. Mean of the sample, that is x bar, is given to be 171.38. Standard deviation of population sigma is given to be 3.3. Mean of population mu is 171.17. Now standard error need to be evaluated, which is governed by sigma by root of n, which is 3.3 by root 400, which is 0.165. So the answer is option D. Going to our PowerPoint presentation, so the option for the standard error of mean is the D option as per PowerPoint, which is 0.165. 31st question, a random sample of size 5 is taken from a population containing 100 units. The sampling observations are 10, 12, 13, 7 and 18. We need to compute the estimate of the population mean. Now sample size is given to be 5, population size is 100. Now sample observations are 10, 12, 13, 7 and 18. So we need to calculate the x bar, that is the mean of the sample size, whatever the samples, which works out to be 12. Now estimate of the population mean is nothing but the x bar itself. Here it will be 12. So the answer is option C. Going to our PowerPoint presentation, it is option C, which is 12. So estimate of the population mean is 12. 32nd problem, find the sample size such that the proportionality of the sample mean differing from the population mean by not more than 1/10 of its standard deviation is 0.95. Going to our worksheet, given that x bar minus mu equal to 1/10 of sigma, which is 0.95, means it has a 95% confidence level, which implies z is equal to 1.96. We know that x bar minus mu by sigma divided by root of n is equal to 1.96. On simplifying, we get the value of n equal to 384.16. So the best option is option D. Going back to our PowerPoint presentation, the sample size works out to be the D option, which is 384. 33rd question, a random sample of 200 articles taken from a large batch of articles contains 15 defectives. Then the estimate of the population proportion of defectives is as follows. Sample size is given to be 200, out of which defective happens to be 15. Proportion of defective, or what we can say as the estimate, we need to estimate the population proportion of defective is nothing but defective in the sample 15 by the sample size, which works out to 0.075. So the answer is option A. Going to our PowerPoint presentation, it is option A, which is 0.075, which is the estimate of the population proportion of defectives. 34th question, SC, or the standard error of mean, is defined as the standard deviation of the sampling distribution of mean. This is as per the definition of standard error. So we go to the option, it is the C option. So the standard error of mean is defined as the standard deviation of the sampling distribution of mean. C option. The 35th question, the difference between the sample standard deviation and the estimates of the population standard deviation is negligible if the sample size is sufficiently large. That is C option, which says sufficiently large, because using the principle of law of statistical regularity. So once again, the difference between the sample standard deviation and the estimates of the population standard deviation is negligible if the sample size is sufficiently large, or the C option, using the principle of law of statistical regularity. 36th problem, a random sample of size 26 is taken from a population which is normally distributed. The standard deviation of the sample is 5. The standard error of mean is worked out as follows. the sample size is 26, sigma is given to be 5, that is a standard deviation, and standard deviation is given to be 5. So using the formula for standard error of mean in a normal distribution, sigma by root of n minus 1 for a normal distribution, because the sample size is very less than 30, we use this formula. So equal to 5 by root of 26 minus 1, which is equal to 5 by 5 equal to 1. So the option is B. Going to our PowerPoint presentation, it is the B option, which says it is equal to 1. 37th problem. Which sampling is affected most if the sampling frame contains an undetected periodicity? It is the systematic sampling. As per the solution in your PowerPoint, it is the C option, which is systematic sampling. It's because the concept of types of error in that, if you notice, the sampling which is affected most if the sampling frame contains an undetected periodicity is only systematic sampling. So the answer is C option, which says systematic sampling. 38th problem. In a simple random sampling, every item of population has equal chance for selection. This is a very definition of simple random sampling. So going to our PowerPoint solution, it is the B option, which says every item of population has equal chance for selection. So it is B option. 39th problem. Interval estimate of a statistic is a set of values specifying with lower and upper limit for the estimates. This is, as per the solution, you can see is the A option, which says a set of values specifying with lower and upper limits for the estimates. This is as per the definition of interval estimator. So A option, a set of values specifying with lower and upper limit for the estimate. 40th problem. The standard error of the sampling distribution of mean is governed by the formula sigma by root of small n, where sigma is the standard deviation of the population and n is the sample size. Now this is as per the formula which is normally used. So it is the A option, it says sigma by root of small n. 41st problem. A die is thrown 400 times. A number of defectives was found to be 20. The standard error of population proportion needs to be computed. Looking into our worksheet, the die is thrown 400 times can be taken as a sample size n equal to 400 and defective found equal to 20, that is x. Now probability of finding a defective would be x by n, that is 20 by 400, which is also a population proportion that is defective. Now that can be termed as P, and we need to compute Q, that is which are not defective. So it is 1 minus P, which is probability of not being defective, or population proportion which is non-defective will be 1 minus P, which is 0.295. Now standard error of population proportion is equal to square root of PQ by n. Substituting the values, we get the answer as 0.01089. So the answer is option B. Going to our PowerPoint presentation, it is option B, which says 0.010897. 42nd problem, it goes like this. A random sample of a group of people is taken and 120 were found to be in favor of a certain proposal. If the 95% confidence interval for the population proportion in favor of the proportion is 0.683, 0.817, then the sample size need to be computed. For 95% confidence level, Z is equal to 1.96. Given that x bar plus 1.96 is equal to 0.817 is given, x bar minus 1.96 sigma equal to 0.683. Adding both the equations, we get 2x bar, that is the arithmetic mean or the mean of the sample, equal to 0.75 x bar, but x bar is equal to sigma of the xi by n, which is 120 is the total number of the sample. 120 were taken to be in favor of a certain proposal out of a total sample size. So 120 by n is equal to x bar. So the sample size n works out to be 120 by 0.7, which is 160. So the answer is option B. Going to our PowerPoint presentation, it is option B. So the sample size is 160, out of which 120 were found to be in favor of a certain proposal. So it is B option. Answer is 160. 43rd question. A random sample of 100 apples from a large population resulted in 6 bad apples. The standard error SC proportion of bad apples is worked out as follows. In our worksheet, the sample size n can be taken as 100, bad apples being 6. Probability of finding bad apples works out to be, in that sample, will be 6 by 100. Now, therefore, Q is 1 minus P, which is 1 minus 6 by 100, which is 94 by 100. Now, standard error proportion of bad apples is given to be square root of PQ by N. That is equal to 0.024. So the answer is option D. Going back to our PowerPoint presentation, it is option D, which is 0.024, which is the standard error proportion of bad apples. 44th question. If the population standard deviation is 5 for a population with 80 units, the standard error of the sample mean of size 25 without replacement is. We go back to our work area. Now standard deviation is given to be 5, population n is capital N is 80, simple sample size small n equal to 25. Then standard error without replacement governed by the formula sigma by root of small n into root of capital N minus small n by capital N minus 1. So substituting the values appropriately, we get 0.8343, which is close to the answer 0.83. So the option is A. Going back to our PowerPoint presentation, the standard error of the sample mean of size 25 without replacement is option A, which is 0.83. 45th problem. A random sample of size 100 is taken from a very large population with a standard deviation of 5. The standard error of the population mean is worked out as follows. Using the formula for standard error as sigma by root of small n, sample size small n is equal to 100 and sigma standard deviation of the population is 5. So 5 by root of 100, which is nothing but 0.5. So the answer is option B. So going by our PowerPoint presentation, it is B option, which is 0.5. So the standard error of the population mean is 0.5. 46th question. In measuring reaction time, it is estimated that standard deviation is 1.08 seconds. Find the sample size at 95% confidence interval if the error of estimate is not to lead 0.18 seconds. Going to our work area, now sigma is given to be 1.08 seconds and for 95% confidence level, Z is 1.96. It's a very standard thing, and the error which error uh, and the error of estimate is not to lead 0.18 seconds. So E is 0.18. Now your sample size is given by the formula sigma squared Z squared by E squared. Substituting those values, we get 138. So the answer is option C. Going to our PowerPoint presentation, the sample size works out to be 138, which is the C option. 47th problem. In stratified sampling, uh, sampling size is proportional to the population size. This is the very definition of stratified sampling. So in out of the four options, the answer is A, which is sample size is proportional to the population size in stratified sampling. This is the very definition of stratified sampling. 48 question. Sample mean is an unbiased estimator for the population mean. It is consistent estimator for the population mean. It is efficient and sufficient estimator of sample mean. So all the three A, B, C options. So it is D option, which says all A, B and C. So that is given as the D option, all A, B and C. All the three are applicable. So that makes a sample mean. This is as per the properties of sample mean. 49th question. The number of possible samples of size 2 with replacement from a population containing 40 elements is governed by that formula capital N whole power small n. That is, if the population is capital N and the sample size is 2, then the number of possible samples of with replacement would be capital N power small n. Here it is 40 squared, that is 1600 as per our PowerPoint presentation. It is B option, which says 40 squared is nothing but 1600. The last question, that is the 50th question of the session, it states a person threw 10 dice 500 times and obtained 2560 times 4 or 5 or 6. What is the sample proportion? Going to our PowerPoint worksheet area, sample proportion P, or the probability of getting these values, is number of successful events is 2560 times. 10 dice thrown for 500 times means 5000 times, equivalent to throwing 5000 times one die. So the probability, sample proportion probability or proportion would be rather sample proportion is nothing but the probability, which is x by n, that is given by 2560 divided by 5000, which is 0.512. So the answer is option C. Going to our PowerPoint presentation, the sample proportion works out to be 0.512, that is the C option. So it is 0.512 is the C option. Thanks for your patient viewing of the video session on the topic, the solutions for the topic on sampling theory. For any doubts or queries, you are requested to mail to the following email ID. It is queries@greymatteracademics.com. Thank you. Bye bye. See you next time.